Hello, my name is Brady Ng. The date is June 10th, 2025. I am a junior at Walter Payton, and today I will be teaching you how to perform the mean value theorem as a part of my AP Calculus AB final project. But first, some background on the mean value theorem. The MVT, as I'll be calling it, applies to functions that are continuous and differentiable on a closed interval. This theorem also serves as a foundation for other important theorems, like Rolle's theorem, which you might learn after learning the mean value theorem. This theorem also has applications in physics and engineering concepts. If you want a quick example of what these problems might look like, this graph here is a pretty good basis as to what these problems will look like, and you may go back to this graph later to see how this actually works. But first, what is the mean value theorem? The mean value theorem states that if f of x, so this can be any function, is continuous and differentiable on the interval a to b, then there exists a point c, this point can be any point, between a and b such that f prime of c equals f of b minus f of a over b minus a. So I know I just said a lot of mathematical terms, but what this really means is that at some point c in the interval, meaning that this point c must fall between a and b, the instantaneous rate of change of that point is equal to the average rate of change over the interval. Okay, so now let's look at some problems. So our first mild problem will be so the first part of the problem is find the average rate of change of f of x. So f of x here is 3x squared minus 6x plus 2 on the interval -1 to 2. So we used this equation seen in the last slide to find that average rate of change, which is simply just the rise over the run. So we take f of 2, our higher boundary, minus f of -1, our lower boundary, and then we divide that by the difference between the boundaries, so 2 minus -1. We find that by plugging in 2 into f of x, we find that f of 2 is 2. By plugging in -1, we find that f of -1 is 11. So now that we have all of our points, we plug them in. So now we get 2 minus 11 divided by 2 minus -1, which is -9 over 3 and -3. So now we know that the average rate of change of f of x on the interval -1 to 2 is -3. So now for the second part of this problem. According to the mean value theorem, there exists a point of f of x on this interval that we were just talking about, whose slope is equal to -3. Find the x value of that point. So, since we know that this -3 is the average rate of change, then according to the mean value theorem, there must exist this point. So in order to find this point, as seen here, we need to take the derivative of f. So we take the derivative, so we have f of x equals 3x squared minus 6x plus 2. We take the derivative f prime of x, and we find that this is equal to 6x minus 6. But we're looking for the point x that gives us -3. So we set up the equation, f prime of x equals -3. 6x minus 6 equals -3, and after some arithmetic, we find that the x value is 1/2, meaning that the x value of the point whose slope is equal to -3 on this interval is 1/2. Now, let's look at a more difficult problem. So we have this graph. You can take a few moments to look at this graph before I start. Table. Okay, and then it's also important to acknowledge that g is a differentiable function. As you remember, being differentiable, so if a function is differentiable, it's also given that it's continuous. So it must be differentiable for the mean value theorem to be applied. So our question is there a number c on the interval -5 to -3 such that g prime of c equals -4? So the important thing to realize with this problem is that it's not asking us for the entire boundaries of this table. It's only asking us from -5 5 to negative 3, which I've highlighted using these marks on the sides here. So we will only be taking into account these 3 rows. So the first step of this problem is to finding the average rate of change of g of x on this specific interval. So similar to last problem, we do rise over run g of negative 3, the higher boundary, minus g of negative 5, the lower boundary, minus 3 minus negative 5, and after some arithmetic, we find that the average rate of change on this interval is negative 4. So then we can utilize the MVT. Since g of x is both continuous and differentiable on this interval, in the entire table, then since the average rate of change of g of x on this interval is negative 4, then the mean value theorem states that there must be a value c in this interval such that its slope is negative 4. Because the mean value theorem here allows us to confirm the question, to confirm that there must exist this point, because it's asking us if there's a point that has this slope, which is actually the average rate of change on the interval. So since mean value theorem states that there must exist this point, we can confirm it to be true. Thank you.